Okay, last subtopic, which is on potentiometer. Okay, in this subtopic, you should be able to explain the principles of potentiometer and its applications and use related equations for potentiometer. Okay, so potentiometer, let's consider potentiometer circuit as shown here. So it is balanced when the jockey, which is this one here, is at position on this wire AB here. It is balanced when there is no current flowing through the galvanometer here. Okay, so G would be equal to 0. Okay, so bila G equal to 0, it meant that it is balanced. Okay, so when it is balanced, the potential difference that is being measured will be equal to the voltage across AC. Okay, so Vx here will be equal to VAC. Okay, so usually this would be EMF2. Dia akan equal dengan VAC di sini. Only when the G is equal to 0. Okay, so that is the concept, and then the application for potentiometer are to compare the EMFs of two cells, and then to measure an unknown EMF of a cell and measure the internal resistance of a cell. Okay, so that is the application. Okay, so untuk compare the EMFs of two cells, let's look at this. So wire AB is a wire of uniform resistance, so it has uniform resistance, and this is the jockey lah. J is the jockey. Okay, so an accumulator X, just this one, the battery, maintains a steady current through the wire AB. So ada current flowing kan. Okay, so remember, bila G equal to 0, EMF1 here will be equal to the volt at AC. Okay, VAC. Okay, so VAC pula, they equal to I, resistance at point AC saja. Okay, resistance AC. Ni Ohm's law lah, V equal to IR kan. Okay, and then resistance pula, we can calculate using this equation here. Okay, so from these two, we can then get EMF1 to be equal this value. Okay, ini untuk bila switch 1 is turned on lah. Okay, bila switch 2 pula yang turn on, this one tiada lah. Okay, kita ada E2 saja. So EMF2 ni pula akan at point VAD lah. Dia akan di VAD, not VAC sudah. Okay, AD sudah. The jockey is here. This is the distance when it is balanced. Okay, so at this point, EMF2 pula akan equal to the voltage across VAD. Okay, across wire AD. Okay, so again, we use Ohm's law, AD equal to V equal to IR. So ini pun sama. So substitute, we'll then get this equation. Okay, so from that, we can then divide EMF1 divide by EMF2. So we'll get this concept here. Okay, so you will understand this more when you start doing the exercises lah. Okay, now the second application, to measure an unknown EMF of a cell. So by using the same circuit as shown in figure 27, so we are gonna calculate kejap ah. Oh, it's not figure 27. This one should be same circuit, which is figure 26 lah kan, 26. The value of the EMF can be determined if E1 here is replaced with a standard cell. Okay, a standard cell is the one which provides a constant and accurately known EMF. So dari situ kita boleh kira EMF2 lah. Sebab so if we have EMF1, we can just directly use this equation here just to find EMF2. Okay, okay, and then lastly, to measure the internal resistance of a cell. So this is the circuit here. So when S is open, EMF1 here will be equal to VAC. VAC untuk ini saja. Okay, so ini Ohm's law, and then this is resistivity punya formula. I mean resistance punya formula. Then we'll get this one, and then when S is closed, the voltage V will be equal to VAD. Okay, so this internal resistance here is equal to this one, which is this one dapat dari E I R plus R. Dia tidak guna itu, sorry. Dia guna V minus IR. Okay? Okay, so macam salah aja. V equal to minus IR. So R is equal to V E minus V over I. Okay, dia diguna yang ini. V is equal to EMF minus IR. So dapat yang ini. Okay, and then this one is Ohm's law again. Then dapat ni lah. Okay, it's okay. You will understand this more when you start doing the examples. When I start explaining the examples. Okay. So, and then when you substitute equation E1 and V into the internal resistance formula tadi, equation tadi, you'll get this one lah. Okay. So, we can then calculate it by plotting a graph of 1 over length against 1 over R. So, we'll get this one. So, the gradient will tell us the internal resistance divided by the original length. Okay. You'll understand it more when I start doing examples lah. Okay. Right. So that is mostly the most important concepts of potentiometer is you will be mostly using potential divider punya concepts untuk solve potentiometer juga lah. Okay. But the most important concepts is when G is equal to 0, the voltage at where the balance thing here, the VAC here would be equal to Vx here. Only if the G is equal to 0. Okay. So that is on potentiometer.